Bismillah Rahman Rahim. Today we will discuss a nuclear chemistry. Okay, so what is nuclear chemistry? Uh, the first lecture of nuclear chemistry is about the nuclear structure. We will discuss the nuclear structure, the size, and the real composition of the nucleus of an atom. So first, let's discuss a nuclear chemistry. This is nuclear chemistry. So from word nuclear, it is very much clear that nuclear means a nucleus. So what do you mean about the nucleus? Nucleus means what type of nuclear changes that take place within the nucleus of an atom. So this is the chemistry same. So the chemistry, which is a study about the nuclear changes that take place within the nuclei of the atom, that is known as a nuclear chemistry. So from this word nuclear, it is very much clear that this chemistry is only and only a study of the nucleus of an atom. What's the composition of the nucleus, how the nucleus is an atom, what are the fundamental particles, okay, uh, uh, what is the number of the nucleons, what type of nuclear changes takes place. So this whole study is about the nuclear chemistry. So let's discuss about the nucleus of an atom. Suppose we have this a nucleus. So this is the nucleus. So we call it this is the nucleus. Nucleus is the positive charge, and these are the electrons. When we compare the radius of an atom and the radius of the nucleus, so there is we can say a bigger difference, okay, between the radius of the atom and the radius of the nucleus. So radius of an atom is 10 power minus 10 meter. On the other hand side, the radius of the nucleus is between 10 power minus 14 and 10 power minus 15. So the radius of a nucleus lies between minus 14 and minus 15. So you can see that how smaller the nucleus is than the radius of an atom. How can we compare the radius of a nucleus with the radius of whole atom? Suppose we have this a room. This is a room, okay? Okay, this is a room, and a very smaller, we can say the object are very small. That is stone is lying, okay, at any corner of the room. So this smaller object is known as the nucleus, and this whole area is known as the room. So you can also see the major, we can say that the difference in the size of the nucleus, okay, and the size of the atom. So how much a nucleus is smaller. So I think that this is a very difficult to study the nucleus, okay, in a very detail. So, difference of the size, and another that we need the strong experimental data that they can verify that how a nucleus is different from the size of an atom. So this was about the radius of an atom, the radius of the nucleus. Now let's discuss the classification of the nuclei of atoms. So we have the different, we can say that the nuclei. First, we have the isotopes. Okay, so nuclei are classified as isotopes. We have isobars. You can see that isobar. Then we have isotones and isosteres. We will study. Okay, in a detail. So first we have to learn about the isotopes. So isotope is made up of two words. Iso means the same and top means a place. It means that the atoms of an element that having the same place in the periodic table. Of course that isotopes are the same place in the periodic table. It means that iso same refers that the atoms that have the same atomic number but a different mass number. For example, that we have these three isotopes of hydrogen. This is a protium, this is a deuterium, this is a tritium, and this indicate they have the same atomic number 1 1 1. if we find the number of electron in this protium, so electrons are 1 and the protons are 1, and the neutron will be 1 minus 1. So we have to subtract the atomic number from this mass number, so this will be the 0. Again, you can see here that we have the same number of electrons, same number of the proton, and the 2 minus 1 that we have 1, so neutron, the number of the neutron you can see here that we have 1 for the deuterium. And for the tritium that you can see the number of electron, number of the proton, both are the same. So 3 minus 1, so this will be answer will be the 2. So the number of neutrons, tritium is a 2. Another that we have the isobar. So what's the meaning word iso? Iso means the same, bar means heavy, means equal heavy. So it means that the two atoms are two elements that they have the same atomic mass, same mass number. So the same atomic mass or the mass number but a different atomic number are known as isobar. Bar means heavy. For example, you can see here that we have the carbon. So the atomic number of carbon is 6 and the atomic number of nitrogen is 7. You can see here that both these elements that they have the same mass number 14, 14. So we call these two the isobars because both of the isobars we have the organ. You can see here that we have the atomic number of argon is 18 and the mass number is 40, and this is the calcium. This is the 20 atomic number and this is the 40 is the mass number. So what's the same here? The same is the, we can say the mass number, and the different is the atomic number. So you can see here that they have the same mass number but different atomic number, so we call them isobar. So you can see that I have calculated the number of electron, proton, neutron for the organ and also for the calcium. So this is the same number of electron, proton for organ. So neutron is 22, 40 minus 18 is 22, and so this can be applied also for the calcium. Another that we have isotones. The third classification is iso. Iso means the same. Tone means the neutron. It means that when the number of the neutron is the same. So atomic number is different and the mass numbers are different. So this is a very big criteria how the isotones are the different from the isobars and isotopes. So in isotones, the atomic number and the mass number, they are the totally different. For example, we have the lithium 3 atom number, 7 is atomic mass. And for the beryllium, we have the 4 atomic number and we have the 8 the mass number. So number of electron and protons is 3 and the neutron is 4. So 7 minus 3 is 4. And again, same cases with the beryllium. So the 4 electron, 4 proton and 8 minus 4. So this will be 4 neutron. So number of neutron you can see here that I have underlined these 4. I have also underlined these 4s, okay, with a red marker. So you can see here this is 4. So if the number of the neutron the same, so we call it isotone. Another that the fourth classification is the isosteres. You can see that iso is being repeated prefix, okay. So iso means the same and stairs means the group of two or the more atoms. So what we call it that the same atoms are the same molecules or ions or which have the a similar size. For example, you can see here that I have CO2 carbon dioxide gas. So valence electron is a 16. Why 16? You can see here that the carbon has atomic number a 6. So it contains a 4 valence electron. And on other hand side, when we have two oxygen, so one oxygen contains 6 valence electron. So the other two, 6 plus 6 is 12 and 12 plus 4 is 16. So again, this is a nitrous oxide, okay? This is a nitrous oxide. So valence electrons are also the 16. If the number of valence electron in the molecules in the 2 or 3 molecules are the same, so we call them the isosteres. So they have also same number of the atom. For example, you can see here this is nitric oxide. So this is a 3 number of atom, 2 of the nitrogen and 1 oxygen 3. And again, For carbon dioxide gas, we have also the 3 number of atoms. So we call them the isospheres. Now let's discuss about the size of a nucleus. For example, we can say that the size of a nucleus depends on the number of the nuclei. So size of the nucleus size, so this is the volume. So volume of a nucleus is directly proportional to nuclei and how many number of the proton and neutrons are here. So this volume is directly proportional to A. A is a mass number. For example, if we say that we have this spherical, okay, an atom, and this is a nucleus. So from this central point to this point, this is the R. So we call this a radius, okay. But when we discuss the volume, so the volume for the nucleus is this 4 by 3 pi r cube. So we consider the nucleus as a spherical. So the volume for the spherical, we can say, object is 4 by 3 pi r cube. So here you can see here that volume is directly proportional to the mass number. Now what's the value of the volume? So value of the volume is this 4 by 3 pi r cube. So put here for the V 4 by 3 pi r cube directly proportional to I. And again you can see here that this value 4 by 3 pi, this is the constant. So I call it, this is a constant, okay. So this is a constant value. So this will be r cubes directly proportional to I. Now you can see here, if this is r, this is in a power, okay. So we can also write this like this one. So this is or, okay, it's a directly proportional 3 and this is a radical A. So this also can be written like this one, or it's a radius directly proportional to mass number, okay, bracket over 1 by 3. If this is the sign of the proportionality, if I remove the sign of the proportionality, then I have introduced a new constant. This is or not, and this is a bracket a mass number bracket over the power by 3. So this is or not. So the value of the or not is a 1.2 in 10 power minus 15 meter, or we can write it like a 1.2. This is the Fermi. 1.2 Fermi are this both valued, okay, we can write for the R naught. If we talk about the density, so what is a nuclear density? Nuclear density we can define is, it is the, we can say, the ratio, it is a ratio of the mass, we can say, of a nucleus divided by the volume. So it is a ratio of the mass over the volume. So density represented by the rho. So you can see here that mass, we call it, this is, we can say, the mass number, and we have to multiply it to 1 atomic mass unit divided by the volume. So this is the A, 1 atomic mass unit, and this is a V. So what's the formula of the V? 4 by 3 pi r cube. So again, this is the same formula of A into 1 mu divided by 4 by 3 pi. And what's the value of R? Now that we have calculated the value of the R, so this is the value of the R, okay, this is the value of the R. So we will put the value of this R, okay, in this equation. So this will be the bracket or not bracket A, this is at mass number bracket over power 3 bracket over the 3. So 3 will be cancelled out. So we have uh, these, okay, we will have this reduced form of the equation A into 1 mu divided by 4 by 3 pi or not cube, this is A. So A and A will be cancelled out, so we will have this value. We know that 1 mu is always equal to 1.6710 power minus 27. This will be the, okay, kg. So this will be the kg kilogram, and this will be divided by 4 by 3. This will be the pi and bracket 1 point. So this is a pi, and what's the value of r naught? That we have calculated the value of r naught is this. So put here. So this is 1.2 in 10 power minus 15 meter bracket over 3. When we will solve this, so we will get exactly this nuclear density. So this will be the 2 into 10 powers 17 a kilogram per meter cube. So this is a nuclear density. So nuclear density for all the, we can say that the nucleus of an atom is the same irrespective of their sizes.